Hey, hey, Mr. Warrior. Doing a little guitar riff there, you know, playing my little air guitar. Thanks. How you guys doing? Hope everything is good. We're getting near the end of this module. Yoo-hoo! Yay. All right, let's take a look. We're looking at the same topic we have been looking at. It has been the making like units numerically. That was when we moved away from the area model, which of course you could always use the area model, trying to move us away from it in the sense that we can start solving problems numerically by looking at the value of fractions, and we're going to continue to do that. Let me go ahead and get a working pen here, see if my little tablet is going to be, it looks like it's glitching on me. Uh-oh, not good. Let's see, hopefully it'll work. I don't know, sometimes it does that and I have to reinstall, do that, all that fun stuff. Anyway, here we go. Here's our objective. It says that students will be able to strategize. You know what a strategize? They use that as a verb. How interesting. Okay, a verb. And it's to solve multi-term problems, and we'll talk more about that as we get to there. First of all, it says for a large order, Mr. Menig made 3/8 a kilogram of fudge in his bakery. Hey, I didn't know Mr. Menig had a bakery. Cool. He then got 1/6 kilogram from his sister's bakery. I must keep it in the family. If he needs a total of 1.5 kilograms, it says how much more fudge does he need to make? Okay, well, let's go ahead and get a nice good working pen. And, you know, I rarely use, let's go ahead and get the blue, make it all blue. Oh, first I need to go ahead and set up my tape diagram. So we'll take this here. Come, follow me. There you go. There. It looks like that'll work for me. Make it a little bit longer and skinnier. You know, it looks like that we have in his own bakery, which we could go ahead and mark, is 3/8 kilogram. Okay. And I guess I could sneak that in there. 4/8 would actually be half. So we think that it'd be about here, but I'm just going to put there. He needs actually a total 1.5 kilograms. You could actually almost say this is probably going to be a lot larger than 1 unit. This was, who was this one? This was Mr. Menig, right here. And let's just put for the M. And then, of course, he then got 1/6 kilogram from his sister. So we'll kind of put that here. That's kind of small. Okay. And we'll say that was the amount that was basically made. So he made some, got some from his sister. It says he needs a total of 1.5 kilograms. That sounds like that total here, doesn't it? Yeah, the 1.5 kilograms for the total. And then, of course, he needs more. So this is how much more. And that much more should let us know right away we're comparing, which usually means we're subtracting. Does he need to make? And so this is going to be how much more he needs. Yeah, my little pen is not working all that well here. I apologize for that. So let's go ahead and look at it, and then we'll think of it this way. Now, looking at the problem, we have our whole here, what we're trying. That might be the best thing to do is to just take that 1 and then 1.5, and we're going to subtract 3/8 from that, as you can see. And I'm going to subtract that first, so I'll put that in parentheses. But also I'm going to be subtracting the 1/6. Again, this is how much, you know, he needs in total. This is how much he's made. This is how much he got from his sister. So how much more will he need? So what we're determining, this is our question mark. So make sure that that's clear. Okay. Of course, that's going to equal whatever that amount is. Now we can go ahead and we can subtract here by getting a common denominator. 1/2 we know is the same as 4/8, correct? And these are ones we can do mentally now rather than writing out our common denominator every time. We can look at the 2 and go, wait, okay, I'd have to multiply. Okay. Now, oh, by the way, you could multiply the 2 and the 8, and that would give you a denominator of 16. But that's much larger than we need, because if you were to get the multiples of 2, 2, 4, 6, 8, you'll see that it actually goes into 8 without any remainder. Therefore, we can use 8 as that denominator. So 1/2 again, 4/8. Now we also have to add on, and if we're going to make that 8s, then we have to make that eighths as well. Now you can see that we have, right here, we have 12. I'm putting it in this form right away. Remember, if you added those, it would give you this. This is all of that right there. Not trying to confuse you, young friends. So 12 eighths minus 3 eighths then is going to give us 9 eighths. And we're going to subtract 1/6 from that. We keep on moving. So I'm going to come down here to make it a little less confusing. Oop, eraser. I made that wonderful boo-boo. Boo-boo. Hey, remember Yogi? You guys remember Yogi Bear? Hey, boo-boo. He's a bear always getting food from the people in the park. Okay. Yeah. What does that have to do with our math problem? Not a lot. Just that I made a mistake. Okay. Move on. 9 eighths minus 1/6 is, no, it's something. We have a problem here. Now 8 will go into 16. I'm looking at multiples now. I don't know if I want a denominator of 48. That's really large. So if I look at the multiples, I can think 6, 12, 18. That's not working. Ha-ha. 24. I knew there was one. Okay, so what we're going to do here is I'm going to bring this page down just like a little bit. We'll put 24 here, 24 there, 24 everywhere. Yeah, my pen is really, really working poorly today. Multiply that by 3, and then you do that by 3, basically, right? We get 27 then, and now we have times 4. Times 4. Doesn't even look like a 4. It looks like a really strange 7. Okay, and then, so that's going to put us 4 up there. Now giving us 27, that's going to be 23 over 24 kilograms. So if we were to write this out, I guess we could say Mr. Manig, there we go, trying to make, needs 23 24th kilogram, okay, more. Okay, keyword there, fudge. Yeah, we solved that. Now, you could always go back and check your work. It'd be a lot of work, but you could still always take this, add this to your 1/6, to your 3/8, and see if it gets you back to 1.5. This is almost 1, so we can look at the reasonableness of our answer. Is that answer reasonable? It's almost 1 whole. Here's 1 whole. 3/8 is about a half. So you could say you have 1.5 there, right? And 1.5 and 1/6 is really, really small. So would that all come back to 1.5? It looks like it on 1, almost 1.5. Yeah, it looks like that's really close. Our answer is definitely reasonable. Okay, let's move on to the next page here. And let's also do, what do I want to do here? Trying to think. We'll do this one. Okay. That's the letter. Let me just tell you, it's the letter C. Yeah, in case you don't know that letter of the alphabet. Okay, just one of them, please. Okay, whenever I do those zeros and C's and P's, and it always does that to me. Let's do red here. We have a new problem here. It says during lunch, Kareem. Yes, Kareem drinks 2 3/4 cups of milk. That should be cups. Oops. Of milk. Okay. Boy, make the body strong. Denise drinks 3/8 cup of milk. Sandy drinks 1/6 of milk. Boy, we have some milk drinkers here. How much milk do the 3 students drink? Ooh, that doesn't say add. Okay, all 3 of them. Okay, that RDW, read, draw, write. And I'm reading it carefully. So this seems pretty simple, straight across. All right. And be nice, please. Getting my a glitchy video today. Hopefully I'll get through it. Sometimes it won't ever come back. All right. I'll give you something fun to look at, something different. Whoa, Mr. Wara, your video was like really going crazy, man. I was wow. Yeah, right. Okay. And now we have the drinking part. Kareem. And it looks like he drank a lot of it. Oh my goodness, 2 3/4 cups. So we don't even know what it is. I don't know how. Some of you might get stuck thinking, I don't know where to draw my line. And you know what? It really doesn't matter because we're not actually trying to draw that amount to actual scales, the way we would say that. This is just actually the visual, I'm just learning to speak, the visual representation of our problem. And that's what we're doing here. That's it. And this was obviously was cream, so well, I guess I could use the same color. Make it easy there. And his name, by the way, is spelled K-A-R-I-M. I am always amazed how often names are misspelled in the classroom. Yes. So then Denise comes along and she drinks 3/8 cup. By this point now, you should start thinking, when you see these fractions, to look at them. I'm going to put just the letter D for Denise. You should start thinking to yourself that how much is that? 3/8? Look at that. That is almost a half cup. See the 3/8? 4/8 is a half. See that? Almost 3 cups. So when you look at fractions, don't write just the numbers down, not knowing what you're doing. And then, of course, we have 1/6 cup, and this would be Cindy. I'll spell her name out since I have the room, although it's very sloppy. I apologize, Cindy, really. Now let's add them all together because that's really the goal here. Okay, 2 and 3/4 cup. Okay, plus the amount that Denise drank, plus. Oh, wait a second, you know what? I know when I initially wanted to write this problem down, I wanted to put a 1 there. Oh, that changes the problem. Okay, so let's just blooper. Mr. Ward's first blooper. No. Of this video. So it should be 1 and 1/6 cups of milk. Okay, so she drank actually more than Denise. So let's go ahead and continue doing it that way. As you can see, I made the correction here. So now we'll put it here. Okay? Hope I didn't lose you guys. Now we have the problems, and we're just going to add these all together. And okay, how should we do this? This is easy here. 4 goes into 8, so 3/4. Hello, that would be times 2 times 2, 6/8. Does that sound right? Times 2 times 2, it does, 6/8. Sometimes it's 6/8. Oh, 4/6 is 2/3. Yeah, sometimes I look at the fractions and I hesitate, not trusting that I'm doing my conversion correctly into the equivalent fraction. Now we can go ahead and, well, let's go ahead and add it this way. We could put these all as 24s. I was actually just going to add these A's first. I could do that. Why not? You know, because here I see 9/8, so I have 1 more whole, so I'm going to add that to the 2. Did I lose you? 8/8 is 1. We already know we have 9 here. Okay, that's more than a whole, because we only need 8/8 to get 1 whole. I'm adding that 1 whole to the 2, giving me 3. That leaves 1 of those left over. Okay, and 1 and 1/6. Then, of course, I look at this. I see 24 as my denominator. Okay, now I'm putting them down here. Now, again, there's nothing wrong with doing it the way that we were doing it before. Okay, this is times 3. I guess I'm going back to the way that I learned when I was a kid, because that made sense to me. How did you get that common denominator? You multiplied by 3. Okay, then make sure we multiply the top by 3 too. And then that's how we did it. Now here we have times 4. See, times 4. Honestly, I think this way is easier. I'd be curious with you guys. You know, maybe we'll put up a poll and do that. And that is really sloppy. It looks like a 7. Double check here. No, that's 4. That should be a 4. My goodness, Mr. Ward. Yeah, this pen's not being very nice today. So if that's a 4, that's 7/24. And then we have 4 over here. Hope my pen hangs in there. Okay. Now, let's go ahead and write this problem down. 2/3 plus 1/5. Okay. Plus 1/3 plus 1 and 4/5. Okay, I actually wrote my numbers halfway. Now, if you recall in the last lesson, we learned how to solve fraction problems by estimating the answers without using pencils. Do you recall? We did it mentally, mental math. And today we're going to build upon that knowledge. Ooh, what are you doing? Don't do that. Okay. Okay, purple dot, you can stay. We're going to add on to that knowledge. So, like, look at this problem. Is there, like, anything that you notice other than there's a purple dot sticking at the very end of that number 5? Whoa, you know what I see. Look at here. And I bet you already saw it. Do you notice here that we have thirds? Uh-huh. How many of you saw that? Go ahead, raise your hand. Okay, I can't see your hands. So, look at that. We have fifths here and we have thirds. That's great when it comes to adding because Oh, we could switch them around. We could say, we could put our 2/3, add that to the 1/3. Yeah, that's the ticket. And then put our 1/5 here and add that to our 1 4/5. Yes, I like it. So now I could easily add that. Well, look at 3 over 3. That's 1, right? So that's really just 1 plus. And look at this. Look how that joins real nice too. 1/5 onto 4/5. 1 plus 4. 5/5. That's another whole. Plus the whole we have here, we have 2. And look how our answer is 3. Now, I wrote this all down so that you could see. But think about it. We could have done this in our head. We could have just said, 2/3 and 1/3. Oh, okay, that's 1 and that's 2. There's 3. Adding. So looking for that pattern. Now this addresses the mathematical standard. 3, 2, I believe it's number 3. I could be mistaken. It might be number 7. I think it's number 7. Where it talks about looking at patterns and structure. And that's what they mean by looking at a pattern when you start seeing that and how numbers are structured. So let's do another one. Skip to the next page. Woo! Santa Claus! Where'd you come from? Wow, you just kind of showed up. Nice. Hey, you got a gift for me? Can I have that gift right there? What? Yeah? Whoa! Whoa! Okay, easy. Well, Santa, I don't know how you did that. That was a pretty cool trick. I don't know. Oh, can you do that again? Yeah, okay, oh, dude, okay, you're making me dizzy. Is this what, to kind of keep you in shape for the long haul yet? Okay. You know what, Santa? I'm sorry, but we're going to have to let you go. Yeah, okay, I'll put you up there. All right, that's fine. Let's move on. So let's look at another problem here. And, let me do this too. We had that last one, I think, so I'm going to give you this one. Wow, it's kind of weird. 2 of them. Strange. In a row. So let's look at this one, for example. So if we had like 5 and 7/8, and we're subtracting, the actual sum of 1/2 plus 7/8 plus, oh my goodness, it's getting long, 1 and 1/2. And by the way, this is what we're doing. We're strategizing to solve that multi-term. And by the way, the word a term, this is a term, that's a term, and that's a term. So we would say that in this whole problem, we actually have 4 terms. That's what a term is. So we're strategizing how to solve that multi-term problem. While you're looking at that right away, look at what we see here, 1/2 and 1/2. Do you see that? Yeah, that's like really easy. You could right away say, hey, this half onto that half is going to make that 2 and 7/8. So why don't we just do that? So we're going to say that this is going to be equal to then 5 and 7/8. We'll write that number down again. Now remember, PEMDAS tells us that we must do the order of operations. And parentheses to the very first one. Did that voice scare you? That kind of scared me a little bit. So we're going to be subtracting 2 and 7/8. Now I'm really liking this problem here because look at, we have 7/8 here, we have 7/8 here. Well, 7/8 cancels out of 7/8, doesn't it? Sure. So just 5 minus 2, 3. My goodness, that, I have to say, is just too easy. You could have done this actually another way. You could have thought of it in different terms. For example, we could have, since we had adding a 7/8 over here, I'm just going to draw a line. We could have actually joined them differently. Just said 5 and 7/8 minus 7/8. Because that would help those cancel. See, and then we're still subtracting. The reason why I could do that, I can do that because this number is being subtracted. The rest of these are still being subtracted, but I can put my subtraction sign, and then add these two here first together, then subtract them, and that's okay. Now look at that, it cancels that out. Now you have 5 minus, and look at, we talked about that earlier. Here we have 2, because the half added on to the 1 and a half would give us 2, and now we have 3. Same answer. No problemo. Yay! Concept development again. One more. You know, I wish there was just another Santa somewhere. Oh, Santa! Oh, Santa, Santa! Isn't it on this page? Oh, It wasn't, was it? Mr. War, you forgot what page it was on. Oh, is it on this one? It was. Okay. All right, so much for that trick really working. I didn't quite get it to work the way I wanted to. Okay, last problem here, I would say, because this is the last page. Should we do like a really hard one here? Let's do, oh, this one here looks really, really crazy. Let's do this one. Oh, my goodness. Minus 15 minus 4.5 equals 7 3/5. Well, you can see that it's a subtraction problem here, right? Subtraction. Now, there's something up here, minus 15 minus 4.5, and it's going to equal that. So the whole is what we're missing right here. The whole, what we're starting off with. And so what you could do, since the whole is missing, you can add up all the parts to find the whole. So what we're going to do is we're just going to add all these together. Let's add the 15. We're just switching this equation around. We're going to add the 4.5. And we're going to go ahead and add the 7 3/5. And that will equal that line over there. Now you might say, Mr. War, you totally lost me on that one. And I'd say, oh, I'm so sorry. I don't want to lose you. Come on back. Let me show you. Because this problem is really no different. But if you looked at it as saying, say, 24. Okay, and then we had, say, let's say minus 8 minus 10. That's 18. Equals, now if we took all that, 24 minus 18, doesn't that equal 6? It does. 16. Now, all we're doing is we're adding all these together to get back to what that whole number was. Okay? Now, ooh, I didn't call you out here. Get back in there. Okay, now we can go ahead and look at this here. I see halves and fifths. I'm going to turn that into tens. So that's easy. 5 over 10, right? Right over here. So we'll put 5 over 10 because that's a half. 3/5. Well, to get to that 10 here, you'd have to multiply by 2, so you're going to do the top, so that's 6 tenths. 19 there, we have what, 26, I believe? 26 plus, and then we're going to add 11 tenths. We still have another whole here, so we have 26 plus 1 tenth, which of course is going to equal 27 and 1 tenth. Now you have something else that's following the code word. Whoa, that's heavy duty, Mr. War. I forgot to put him in front of there. And then put him on there. And then that there. Ooh, did you catch all that? Give me something to. There we go. Ooh, it got really quiet in here. My friends, live long and prosper.